Course 3, Lesson 6, Converting Measures. So we see our objective is you will be able to convert between units of measure and between the US customary and metric systems. All right, so we're skipping the warm-up and power-up, and we're just jumping right in. So here on page 37 of your book, you'll see we have this conversion chart, so going between different units within the US customary measurement system and the metric system. And so, yeah, for length, capacity, weight, mass. So it's a really good resource. So first, let's look at how many milliliters are there in 2 liters. So again, first, I always like to identify what are you given, and then second, what are you trying to solve for. So we're given 2 liters, and we're trying to solve for how many milliliters are going to be in that 2 liters. So what I like to do is a process called dimensional analysis. So I like to, I'll write it out, but here, so the first thing we start with is a question mark. So what are we trying to solve for? We're trying to solve for how many milliliters, so I'm going to write question mark milliliters, are there going to be in 2 liters? Perfect. All right, so with dimensional analysis, I'm going to look is what we call this method that I'm going over. So I'll just write it down here. So this is dimensional analysis. So what I'm going to do here is I'm going to see in my table where can we go from milliliters to liters. All right, and so what we see is right here. There's 1,000 milliliters in 1 liter. So looking at this example, so some of you might have seen, so like let's say we have two fractions. Let's say we have like 4 over 3 times 7 over 4. If we see that we have the same thing in the top and the bottom, what we can do is we can cancel it. So we just cancel the 4's, then we're left with 7 over 3. So we're going to do the same thing, the same idea, but it's going to be with units. So what I'm going to do is I'm going to go ahead and multiply this by 1, but I'm going to multiply it in a way where 1 is going to cancel out units. So here, if like in the previous example where I had 4 on top and bottom, here I want to have liters on top and bottom. So I'm going to say in 1 liter, we have 1,000 milliliters. And we can always write any integer, whatever it might be, over 1. So basically we have 2 liters over 1 times 1,000 milliliters over 1 liter. So let's just go ahead and multiply everything. So we have 2 times 1,000 is 2,000. And we have the units of liters and milliliters left up top. And we have 1 times 1 liter is just 1 liter down below. So what we see here is that we have the same unit, liters, on top and bottom. So just like in that previous example, it's going to cancel. And we're going to be left with 2,000 milliliters. So therefore, how many milliliters are there in 2 liters? There's going to be 2,000 milliliters in 2 liters. All right, let's go on to a couple other examples. So the information is not provided, but we know that there are going to be 1,000 meters in 1 kilometer. All right, so it's asking how many kilometers are in 5,000 meters. 5,000 meters. So again, dimensional analysis, I do question mark, what am I looking for? Looking for kilometers. And then what are we given? 5,000 meters. All right, and then so again, I'm going to multiply the 5,000 meters, so that meters will cancel by this next, what we call a fraction for right now. So if I have meters on top, I'm going to want meters on bottom, and we see our conversion factor up top is 1,000 meters in 1 kilometer. So instead of rewriting it out, I'm just going to go ahead and cancel units now. So we see meters cancel top and bottom. So we're going to be left with 5,000 kilometers divided by 1,000. We divide 5,000 by 1,000 and we're going to get 5 kilometers. So there are 5 kilometers and 5,000 meters. All right, this next one, James weighed 8 pounds and 10 ounces at birth. So how many ounces did James weigh? All right, so I'm going to go to new slide. So I'm going to say how many ounces equals 8 pounds. I know there's still 10 ounces left over, but I'm just going to go ahead and let's just look at our conversion chart. Let's just take care of the pounds first. All right, so if I look here, I see in 1 pound there's going to be 16 ounces. So let's go back here. So therefore, I know pounds on top, so to cancel it, I'm going to have to put pounds down below. So 1 pound, there's going to be 16 ounces. So if I have pounds on top and bottom, they're going to cancel. And so what we get is we get 8 all times 16 ounces. And so that is going to be, I believe, 128, I want to say. Yeah, 128 ounces. But remember, it was 8 pounds, 10 ounces, so we need to add that 10. So plus 10 ounces is going to give us 138 ounces is going to be the weight of James. All right, let's keep going. So now we have a few examples in our lesson practice set. So we're just going to go ahead and look at let's just look at 2 more. So let's look at D, and let's also look at E. So D tells us 3.5 kilograms of wood chips are needed for landscaping, and how many pounds did I order? So again, what are we trying to solve? All right, question mark, what is it we're trying to solve for? Pounds equals, what are we given? 3.5 kilograms. And then I'll just put it over 1. We have to think, oh man, how many pounds are going to be in 1 kilogram? I go back to my conversion chart. And what we see at the bottom here, 2.2 pounds in 1 kilogram. I covered part of that up when we just cleared up. But yes, we got 2.2 pounds in 1 kilogram. So therefore, in order to get kilograms to cancel, I'm going to put kilograms down here, and then pounds up top. Kilograms will cancel, and we get 3.5 all times 2.2. That is going to give us 7.7 pounds of our wood chips. Okay, so I'll just write wood chips in there. So there are 7.7 pounds of wood chips and 3.5 kilograms of wood chips. I also like to do a check for reasonableness. So here, if I got a number like 28 billion pounds of wood chips and 3.5 kilograms, you've probably held a small weight that might say like 5-10 kilograms on there. Now, would that make sense if it was like 29 billion pounds? No. So it's also good to just always check for, is this a reasonable answer according to the scenario that's provided? And so we see here 7.7 pounds, that is a reasonable answer. Okay. And that's a D right there. I'll just fix that real quick, and then we'll move on to our last example in this recap video. Yeah, so example E, I really, really, really like example E because I believe it shows the benefit of dimensional analysis because we're not doing not only 1 conversion but 2 conversions. So it says, if a typical elevator can hold 1.5 tons and the average adult weighs 150 pounds, how many people can the elevator hold? Or how many adults? So what we see here is we're trying to figure out, so how many adults? So I'm going to do question mark adults equals a 1.5 ton elevator. I'm just going to write T for tons. All right, so now I'm going to try and cancel tons. So if we look back at our sheet here, we see, okay, we had tons and then we had pounds. So I'm going to go back here to the conversion table and see, is there conversion between tons and pounds? Oh, and if we look right here, we see there is. So for every 1 ton, there's going to be 2,000 pounds. So going back to the example, I'm going to say for, and then let me just clean up a couple things just so that's 100% clear, that this here is going to be 1.5 tons. Perfect. All right, so 1.5. All right, so we know that in 1 ton, there's going to be 2,000 pounds. Great. Now, how can I get rid of pounds? I'm trying to get to adults. So if we look back at our question, we see the average adult weighs 150 pounds. So therefore, again, I'm going to put pounds on the bottom to cancel. 150 pounds for every 1 adult. So what we see here is tons are going to cancel and pounds are going to cancel. So what I do is I'm going to do 1.5 times 2,000. And then we have adults up here as our units. And then all over 150. Again, we have no units on the bottom because that canceled. So do 1.5 all times 2,000. We get 3,000 divided by 150. 3,000 divided by 150. That's going to give us 20 adults. Again, check our answer for reasonableness. You've been in an elevator before. Is it reasonable for an elevator to hold 20 adults? Yeah, it might be a bigger elevator, but that's reasonable. But if we got like 50 million adults in one elevator, we know our answer is probably wrong. We probably made a mistake. And again, if we got something that was like 0.000000001 adults, we know, I've never heard of an elevator that holds a fraction of a person. So therefore, yeah, what we can see here is 20 adults. That is a reasonable answer, and that is our answer. All right, in this lesson, again, we looked at converting measures, and then this was the homework for lesson 6. Thank you so much. I hope you have a wonderful day.